Hello students, today I am going to discuss the inverse trigonometric function. That is the chapter number 2 of your class 12th. Okay, so just a small introduction. First is, what is function? No two distinct order pair have a same element, or you can say if you have a y is equal to f of x, is this a function? If y is a function, so for one value of x we can't have two values of y, right? So next is trigonometric function. Trigonometric function, students, if x is equals to sine of theta, and theta is what? Is your angle. And if sine 30 degree, or you can say pi by 6, it will give you the value of 1 by 2. Or if you will take a sine 45 or pi by 4, it will give you the value of 1 by root 2. So these value of theta are the domains, and these are the range. Okay, and students, this is the trigonometric function of domain and range. This is the table of trigonometric functions of domain and range that you have already learned in your class 11th. Okay, so today's topic is inverse trigonometric function, or inverse of trigonometric function. So when I said inverse, means invertible. So in chapter relation and functions, your last topic is about the invertible functions. So in invertible function, if you have a function f such that x to y, okay, and if this function is 1 1 and on 2, means if this function is what? Bijective, then there exists another function g, and g is from what? G is from y to x, and this g is called the inverse of f. It means for inverse, you have to make the trigonometric functions bijective. It means your trigonometric function should be bijective first. Okay, so for example, if you have a trigonometric function sine, you all know that the domain of sine of x is all real numbers, and the range is what? Close interval -1 to 1. So students, here is the graph of sine of x. Okay, you all know that your sine 0 is 0, your sine 90 is what? 1. Your sine pi is what? 0. 3 by 2 is -1. So here is the graph like that. So you can easily observe that this graph is not bijective. And why this is not bijective? Because if you take x1 is equals to pi by 2 and x2 is equals to 5 pi by 2, so you will get a same image. Okay, so clearly student, this is not 1 1, so this is not bijective. Okay, so how will you make this graph bijective? So to make this graph bijective, we have to restrict their domain and range. Students, we have to restrict their domain and range of the function. Means now we will talk about a particular span. Okay, for example, just look at the graph. So if I will take this span, means I will talk about this span only. This is minus pi by 2 to this plus pi by 2, and this is like this. Clearly students, so this is easily you can easily observe that this graph is now bijective, because for every value of x you will get a different images or different values in y. So clearly students, this graph is what? This graph is a bijective function. Okay, so this graph is bijective function. Right, the inverse of sine function. Okay, so your domain of sine of x is what? This is pi by 2 to minus pi by 2 to plus pi by 2, and what is your range of sine of x is -1 to 1. And student, this is the particular span that you have just taken. Okay, so in this particular span, your graph is what? Your graph is a bijective function. And when your function is a bijective function, it means there exists what? There exists an inverse. Okay, and if you have a function from x to y, then when this function is bijective, so there exists a inverse function, and g is from what? Y to x. So in the same case, this inverse, sine inverse, from -1 to 1 to minus pi by 2 to plus pi by 2, such that sine inverse of y is equal to what? X. Now this is called the range of sine inverse, or you can say this is called the principal value range. Okay, let's take another example. Cos of x, trigonometric function cos of x. The domain of cos of x is what? All real numbers. And the range is what? -1 to 1. So here is the graph of cos of x. Okay, you all know that your cos of 0 is what? 1, cos 90 is 0, cos pi is -1, cos 3 pi by 2 is 1, cos 2 pi is 1. Your cos 0, your cos 2 pi, cos 4 pi, cos this all equal to what? This all equal to 1. And students, clearly this is not a bijective function. So again you have to restrict the domain and range of the function. Means now we talk about a particular span. So if I'll take this span is 0 to pi. Okay, 0 to pi, students. So this span, this interval, so you can clearly, so this is clearly what? This is clearly a bijective function. This is a 1 1 and this function is onto, and this function is also onto. So this function is what? This function is bijective function. Okay, so you have to write cos 0 to pi, and again this is the thing that you have just taken. This is 0 to pi, and what is your range? Your range is -1 to 1. And this function is what? This function is bijective function. So when your function is bijective function, there exists a cos inverse. So cos inverse, this -1 1 to 0 to pi. Okay, such that cos inverse of y is equal to x, and this is the principal range. This is the principal range of cos inverse. So in this way you will get the table of inverse trigonometric function. Okay, and student, you have to learn this. This is the complete table of your inverse trigonometric function. Now the properties of inverse trigonometric function. If you have a sine inverse sine of x, so this sine inverse sine of x is equal to x if this x belongs to the range of this inverse trigonometric function, and the range of sine inverse is -pi/2 to +pi/2, means whatever the value is, it should be present in the principal range. Okay, for example, if you have a sine inverse sine 3 pi by 5, so can we write that sine inverse sine 3 pi by 5 is equals to sine pi upon 5? No, because this value doesn't lie in this principal range. So first of all you have to reduce this value. So can we write sine inverse sine pi minus 3 pi by 5? Can we write this? Yes, because student, this is what that you have learned from your class 10th. So your value is pi minus 3 pi by 5. This is your pi. Minus 3 pi by 5 means lie in the quadrant first, and there is all signs are positive, so you will get your positive sign, and pi means no transformation occur, so your sign remains sine, and your theta is what? 3 pi by 5, and this is sine 3 pi by 5. So we can write sine 3 pi by 5 is sine pi minus 3 pi by 5. Okay, and when you solve this, you will get sine 2 pi upon 5. And student, this will equal to sine 2 pi by 5, because sine 2 by 5 is something 72 is equal to 72, and 72 lie in this principal range. Okay students, for example, this is your minus pi by 2 and this is your pi by 2. Okay, so whatever the value is should be present in this principal range, means should be present in a quadrant first or quadrant 4, and this 2 pi by 5 lies in the quadrant first. So this is the answer for this sine inverse sine of x. Okay, so now the second property is cos inverse cos of x. Again student, this is equal to x if this x belongs the range of this inverse trigonometric cos of x. Okay, so students, what if x does not belongs to 0 to pi? So we will transform this x in such a way that this x belongs to this close interval 0 to pi. For example, if you have a cos inverse cos 5 pi by 4, okay, so we have to reduce this value 5 pi by 4. So can we write this cos pi, and this is cos pi plus pi by 4. Yes students, and what is your cos pi plus pi by 4? So this is your pi pi plus pi by 4 means lies in the quadrant third, and in quadrant third only tan and cot is positive. So your cos is what? You will get a negative sign, and pi means no transformation occur, so means cos remains the same, and your theta is what? Your theta is pi by 4. Okay students, and one more thing, whenever you find this minus cos theta, okay, this you can't write that this is your minus theta, because cos of minus theta will gives you cos of theta. So whenever you find minus cos theta, always write cos pi minus theta. Okay, so it means this will becomes cos pi minus pi by 4. And students, this is your pi minus pi by 4 means lies in the quadrant second, and in the quadrant second your cos is what? Your cos is negative, so this is a negative sign, and pi means no transformation occur, and your theta is what? Pi by 4. Okay students, so let's solve this. So you will get this 3 pi upon 4, and this will equal to 3 pi by 4. This is the answer. Why? Because 3 pi by 4 lies in between this principal range. Okay students, so this is the property of cos inverse trigonometric function. Now your next property is tan inverse. If you have a tan inverse tan of x, so this will equal to x. Again, if x belongs to the range of this tan inverse, and the range of tan inverse is what? Upper interval minus pi by 2 to plus 2 pi by 2. Okay, so again, what if x doesn't belongs to minus pi by 2 to plus pi by 2? Okay, so again we have to transform this x in such a way that this x belongs to this this principal range. For example, if you have a tan inverse tan 2 pi by 3, okay, so 2 pi by 3, so we have to reduce this value first. So this 2 pi by 3 means this is equals to pi minus pi upon 3. Okay students, and what is tan pi minus pi by 3? So this is your pi minus pi by 3 means lies in the quadrant second, and your quadrant second, your tan is what? Your tan is negative, so this is tan inverse minus tan. And this is your pi means no transformation occurs, so tan remains the same, and this is your theta is pi by 3. Okay students, this is pi by 3. So now in this case, your tan of minus theta will gives you minus tan of theta, so it means this is equals to what? Minus pi by 3, and this will equals to minus pi by 3. Okay, and pi by 3 lies in this principal range, so this is the correct answer in this case. For example student, for example, if you have a tan inverse of x, so can we write this is equal to x? This is equal to x if this x belongs to what? This x belongs to the range of this trigonometric function tan, and the range of tan is what? Is all real numbers. For example, if you have a tan inverse 2 pi by 3, so can we write this will equals to 2 pi by 3? Yes, because this is what? This is a real number. Okay students, now the second property, the next property is cot inverse cot of x. Okay, again same case, cot inverse cot of x is equal to x when this x belongs to what? Belongs to the principal range. Okay students, the principal range of cot inverse, and the principal range of cot inverse is what? 0 to pi. Okay, and again, what if x doesn't belongs to 0 to pi? So again we will transform x in such a way that it will belongs to this x belongs to what? 0 to pi. So if you have an example, let's take an example, cot inverse cot 9 pi by 4. Okay, so this will equals to like 2 pi plus pi by 4. Again student, because 4 to the 8 plus 1 it gives you 9, so this will equals to what? 2 pi plus pi by 4. So student, this is your 2 pi plus pi by 4 means lies in the quadrant first, and in quadrant first you are all positive signs, so this will gives you a positive sign. And pi 2 pi, in pi 2 pi there is no transformation occurs, so cot remains the same, and what is your theta is pi by 4. And and this is equal to pi by 4, and pi by 4 is the answer because pi by 4 lies in between the principal range. The principal range of cot inverse is 0 to pi. And again student, if I will take an example, is cot inverse. This is cot inverse of x. So can we write this is equal to x when this x belongs to, if this x belongs to what? The range of cot, and the range of cot is what? Is all real numbers. For example, if I write cot inverse of 5 pi by 4, so this will equal to pi by 4 because this is what? This is a real number. So the same case with the cosec inverse and the sec inverse. Okay students, so it is all about the properties and just a small introduction of inverse trigonometric. Thank you students.